In these problems, we're trying to identify the graphs of cube root and fourth root functions. And before we try some of these, let's take a look at what those graphs look like, just the basic functions or the mother functions. So if you have y equals the cube root of x, what's that going to look like? Well, if you're not sure, you might want to start a chart, a table of values. Let's put in 0 for x. We would get out 0 for y, because the cube root of 0 is 0. If I put in 1 for x, I'd get out 1 for y, because the cube root of 1 is 1. So here I've got 0, 0, and 1, 1. With the cube root, with any odd root functions, I can put in negative numbers. That makes sense. And if I put in a negative 1, I get out a negative 1, because the cube root of negative 1 is negative 1. So I've got that point. So far, it looks like this might end up being a straight line. But let's plug in at least one more. I'm going to plug in something that's easy to take the cube root of. I think I'm going to plug in 8. If I do that, I get 2. And since I'm plugging in 8, I might as well try negative 8. And if I do that, I'll get negative 2. So we get something like this. So what we end up with is this kind of squashed-looking S shape. And the graph continues to go up and out there, but up at a pretty slow rate, and down and out there, but down at a pretty slow rate. And this is our basic function for the cube root of x. How about the fourth root? Now the fourth root of x is going to be a lot like the square root. It's an even function, even root. We cannot put negative values in there anymore. So it's all going to happen in this first quadrant. X is always going to be positive, y is always going to be positive. And if you think about a table of values here, you'd get 0, 0, and 1, 1 again, just like for our others. But the next value, let's see, let's put in a 16 here because I know how to take the fourth root of that. The fourth root of 16 is 2. So to get up to 2, it takes all the way until x is 16, so something like that. So what you get is a pretty squished version of the square root function. All right, those are the mother functions. Let's take a look at what transformations are being applied here. Now you can always figure these out by plugging in values and making a graph on your own. But if you know what some of these changes do, it's pretty easy to figure out which graph is which. In this one, we've got the fourth root of x plus 2 under the radical sign, and then plus 2 outside of the radical sign. A plus 2 under the radical sign is going to move it left by 2 spaces. And that makes sense. You can actually put in some negative numbers for x. If you put in a negative 2 for x, under the radical sign you'd get 0. So actually, let's start making a table of values. If you put in negative 2 for x, what you get out is 0 plus 2, or 2 for y. If you put in a negative 1, you'd get a 1 under the radical sign. The fourth root of that is 1. Add 2, you get 3. So we've already got a couple of points. This plus 2, when it's outside the radical sign, actually moves the whole graph up by 2. So we're looking for a shape that looks like our mother function, like that, but has been moved to the left 2 and up 2. The one that appears to have had that done to it is this one down here. And let's verify it by seeing if our points are on there. I've got the point negative 2, 2. That looks like right there. And I've got the point negative 1, 3, looks like right there. So I think we're in luck. We could try testing some other points, but this one's definitely going to work out for us. Let's try one more. All right, here we have a cube root problem, and similar things have been done to it. We've got a plus 6 under the radical sign and a plus 2 outside the radical sign. Now remember, our basic shape is this kind of squashed out S with the origin happening right there. Well, when you add 6 to it, you're going to move it over to the left 6 spaces. When you do the plus 2 outside, you're going to move it up 2 spaces. So let's just glance at these and see which one would fit into that. A and C, it looks like the S shape has been flipped on its side or really squished together. And that would happen if you had some multiple outside the cube root sign, but doesn't look like it's happening in what we've got here. Here we've got 2 of those stretched out S shapes we're used to. And this one looks like it's been moved many spaces, maybe 6 spaces to the right, and a couple up. This one has been moved to the left. So I'm looking the origin point there. That's where the origin would normally be on the base function. So this one looks like it's been moved 6 spaces to the left and 2 up. Now you can try testing this with a couple of points if you want to. If you put in, say, a -6 for x, you should get out a 2 for y. That's this point right here. And you could try a couple of others. But just by looking at these transformations, we can identify this graph pretty quickly. My name is Larry. I'm a teacher at EdVisions Off Campus. It's an online project-based school in Minnesota. If you're interested, you can check us out at lovethischool.org. Thanks.